Okay, so let's go here and floating point division, right? So again, I'll just remind you how the book introduces concepts to us. They will create code here in like one main file, and they'll show you, okay, this is how you divide numbers, and then output the result. We don't do that here, right? In this class, we use a function, which is a block of code that handles some task, like for example here, right? So we'll stick to that convention here. So if we are using floating point division, then we will name this function floating point division. And we request that users of this function send us val1 and val2, two values to us. We create one function variable, so we create a variable in here, and we say this variable will hold val1 divided by val2, and right before we exit the function, we will say return result. Okay. Also, one reminder, like for example, right, like when writing code, always use enter, and to indent, use tabs. Don't use like spaces, because Python is looking for the enter or the carriage return in code and the tab key to know like if we indented our code correctly. Okay, so that's what I'm doing here. Like anytime I go here, I press enter and it sends me to the next line so that Python understands my code. Here I'll simply say return result. Okay, return result. And that's the code that I wrote. Now I want to create one test case for it. So my test case will just simply test, like, let's use floating point to divide two numbers and explore what it outputs. Floating point in programming language means decimals. Okay, working with decimals. So let's use a test case to show this. So we go test. We're still be input proc. I think I'm gonna have to change the code back, right? Because for the assignment on run test, I changed it. So right now I'm gonna have to change that code back. Let me see here. So we wrote this for add numbers. So I start here and then I hit enter. Enter. Notice my indentation is off. So I want to hit enter again and then backspace. Okay. And that makes sure that I have the correct indentation for the Python interpreter. So I say test floating point division. So that's the function we are testing. And I'll go ahead and name it _1. Self is required. We create one assertion, so we say self assert equal that if we use the function floating point division, so we're like, okay, floating point division. So Python kind of knew what it was, but it's still like wondering what it is, right? It's not defined. And hopefully by now you know what to do there, and I'll explain right now. So we have to go back here and we hover over quick fix right here. And then we say add, right? So it's saying that it found a function in the input process output file under source examples b input proc output. So we're like, yeah, that's a function I want to use. And notice that that's it here, and now it understands what floating point division is. I know I say this every time I do it, but I want to make sure students get very familiar with this shortcuts. Okay, so 5 divided by 2, if we're using decimals, then that should be maybe 2.5. Right, so 5 divided by 2, the answer should be 2.5 if we are working with decimals. In this case, yes, we're working with decimals. I have to go and see what I have in run test. Run test. I have homework, so that's not what I'm interested in. So I'm interested in source examples. So source dot examples dot b input pros output. That's what I'm actually, let me see here. Sorry, I'm not thinking. Test dot examples dot b input process output. So again, we're like, okay, so we go to this folder, test examples b input process output. Test examples b input process output. Always in the run test file, we use the name of the file right here. So we can go, okay, so test input process output, friendly enough to fill it in for us. Control C, and then we have to send the file name as a function argument to this module, and now it can run our test case from runtest.py. Runtest.py, run it. I am looking for floating point division. Right here, floating point division 1. The result is okay, meaning my code works as expected, right? So it is doing comparison with decimal numbers. So comes in handy in Python. In other programming languages, we may not get so lucky, okay? Let me see, let's do one more test case. Let's see here. Okay, okay, so jump back to my test file, test input process output.py, right here, okay? I want to write another test case. Enter, backspace, df, test, floating point division 1, but I'll name it to number 2, self. Enter, and I'll say self dot assert equal and we just use different values. We're going to test the same function, right? So floating point division. Notice now it knows what it is because we have this include up here or statement up here, and we'll say like 20 and 8. Like what is 20 and 8? And I think that should also be 2.5. I have to go to run test to test that piece of code. So I'm going to click on run test up here, right here, and I will run it. And I'm looking for floating point division 2 right here, over here to the far right. Okay, so my code works as expected. Maybe I should like purposely make it fail, right? So I'm going to jump back to this one, division 1, and I'll put here like 2.7, some value that should not make this assertion pass. So meaning I should not get an OK over here. So let's see, go back to run test, run it, and down here, notice it's telling me that 2.5 is not equal to 2.7. I reiterate, when you run into these issues, always see your data first. Did I set up my test case correctly? Oh, I didn't, right? So in this case, obviously I didn't, but you would fix your data here if it's not set correctly. If the test case data is correct, then you know that your issue is in your function code, okay? So always remember that, it'll save you a lot of time. Okay, so I will leave 2.7 here. However, I cannot have it running because it's going to make my test cases fail. So I'll put a comment here and just put here that make an assertion fail. That's just an example, right? So if I run this code again, Python ignores this piece of code. It just sees it as text, as a comment. So let me go to run test. Run. And notice now everything is okay. And I don't see an error or a fail like I did here. So notice over here everything's good. So that means, oh, Python is not running this code. It's just there for our information. Questions here?
I have a question.
Right.
So when you're running the test and it says verbosity equal to 2, that's just the number of tests?
That's just to tell the testing utility to show us details, right? Like what's going on in the test case.
Oh, I see. Thank you.
Yep. Okay, so let me go here to source control, and I'm going to put a message here, and this is floating point division. So all of these files are related to floating point division, and so I can safely hit commit. And yes, right? If you make a lot of changes to files, and then, for example, you were typing examples that I write, and then you start doing your homework, and then you finish your homework, and then you see like a list of maybe like 8 files here, and you're like, I just want to check in homework. You can do that by adding each file individually. Like, for example, I want this file. Notice it puts it here. I want this file. Notice it puts it here. Assuming that was my homework, then I could hit commit with a comment here, and that would send that as the homework files. That is important for organization, right? Like, let me go here, bring this window here. It's like a breadcrumb of what you do, right? So, for example, here, notice I have the solution for the homework I give to students, right? So you can always go to your commits and changes and readily see what you were doing. For this class, obviously, like it can help you track like what you were learning, what homework 1 was about, homework X was about. But if you were working at some development shop and you were fixing or adding like a new feature, then you would put like new feature, make guy like do a cartwheel and kill someone, whatever, right? Like if it was some video game. So that's how this comes into play. And if there's errors or bugs, then you can always review and be like, hey, wait a minute, like the bug started happening here, so let me go review this code, and maybe that's where I messed up, right? So that's how this comes into play in the real world, okay? Not just to give you a hard time with like different steps in organizing source code. Okay, in this case, I know I need all of them, so I'm gonna have to stage all of them. And then I'll commit the floating point division example. And I'll go ahead and send it on down to my main repository. Okay, so now I'll jump back to input process output. I'll add some more code down here. So that was floating point with decimals, right? Python can also handle division with whole numbers. So we can look at that right now. Okay, so let me go here, enter. Okay, enter. Like it moved, the cursor moved itself to the far left, right? So I didn't have to do backspace. So that's good. It's programmed into this tool. Okay, and now I want a new function. So I have my examples here, because if I do not have examples, then I'll just go off on a tangent, and I don't want to do that. Okay, so we'll go here, def integer division. We need 2 values, val1 and value2. Colon required, and then we say result equals val1 And then we use the / twice val2, so that tells Python that you want to work division with whole numbers, right? So we'll see how that works. Return the result variable. Now we can go into our test case. So we go to the test input process output file, this one. We can create test case. Def test integer division self is required, and we create an assertion for this test, assert equal, and we are dealing with integer division. We understand we need two numbers, and we will use what values? Let me see what values I used here. Values 20 and 8. Okay, so values 20 and 8. And we should expect, so if we're dealing with whole numbers, 20 divided by 8, so 2, and then we have some remainder. So we're just dealing with whole numbers. So the value we should expect is number 2. Okay, so we're like, okay, so that should net 2. Again, Visual Studio Code is warning us that it doesn't understand what integer division is. Hover, quick fix, and then add from the examples file, right? Enter. Up here, it'll add integer division for us. Okay. Okay, so let's run this test case. We do not have to mess around with run test. It's already configured to run any files in the examples folder for B input process output. So we can safely hit run, but before, let me click down here and say clear so that we can have less output. Now I will run it. And we are looking for integer division, so we have integer division 1. And we are okay. So meaning, like, if you use integer division, what is that? You use 2 /, then you're just dealing with whole numbers. If you send in decimal values, or if you use values that demand remainder, it's just going to ignore the remainder and give you the, what is that called? Quotient? I'm not sure. Who cares, right? Like the results, right? So let me see here. Again, integer division, right? So it's ignoring decimal values, right? If we go back here, we're dividing, actually here, we're dividing 20 by 8. The result is 2.5 using division that returns decimal values. Integer division means whole numbers. Like I'm just working with whole numbers as a return value, as a result. So if we divide 20 by 8, it gives us a value 2, ignoring 0.5. So that's what integer division is. May sound weird, but sometimes, depending on what use case you're working with, you may need that integer division. And I guess we'll do one more, right? So I'll just copy and paste integer division 2, and I'll use values 5 and 2, which is what we used up there. Up here gave us 2.5, but if we're ignoring decimal values, then this should also give us value 2, ignoring the remainder. Go back to run test, run it. Integer division 2, we are okay. So that's good. That's what we are expecting. Questions here? Okay, no questions. So let me go ahead and send this also to my GitHub, I'll click on the source control icon, and I will put here integer division. I will commit. Committing sends all my files that are here, okay? In this case, it's okay because I know all of them are related to one example. Oops, not what I wanted to do. I'll push. Also, you can sync changes. And let me go to my repository, this one. And let's go here. I go to commits. And then we can see the history of examples in this class so far. Okay, so you can always go to my repository. The links are, if you're watching videos, you'll see the GitHub links on the bottom. It'll send you back to the example code that I type in this class. So if you ever need to reference anything and you're not following along, type in examples, which is not required, right? Then you can use my repository. I will get an error, right? So division by 0. So that's not legal in math. So in this case, it'll be the same thing. We'll get a division by 0 error. So let me go here and here. Go my repository. And maybe we should use those in an example, right? So let's go here. Main, we had floating point division and integer division. So I can safely remove these. They're saved already in some commit. So we're like, okay, let's use the floating point division. And we're like, okay, can we collect variables here with input? Yes, so we'll say val1 equals input enter value 1. And then val2 equals input enter value 2. Remember, when we collect with input, the computer reads them as alphanumeric, meaning it doesn't consider them numbers that can be used in arithmetic operations, so we will have to convert them to numbers. So we can do that. So we say, okay, result equals, and we can call the floating point division. So floating point division. Okay, I'm gonna go this route. Input process output floating point division, and I will use val1 and val2, but since these variables right now are not numbers recognized by Python, I have to say, well, you know what, I want you to treat them as numbers right now. So I have to do int and then open close parentheses, int open close parentheses. Then I can print the result. Very simple usage here. So let's go ahead and run this piece. So go here. Down here, notice enter value 1. I think it was 5, right? 5. Enter value 2. 2. Result 2.5, which is what we got for the test case. I can run it again. So enter and use some other values, right? Like 100, and maybe like the value 9. So that'll be 11.1111. Generates decimal values because we are using the floating point division function we created. Okay. We can copy this code here to prompt them for more data. So we're like, okay, after you display the result, give me more data, and we'll say, okay, we want to store some result in that variable, and that'll be integer division, and we send in val1. We have to treat it as a number with int open close parentheses, int, open close parentheses, val2, and then we print the result. So let me go down here, clear, run, 5 and 2, enter value 1, I'll use 5 and 2 again. And notice 2.5, why? We are using functionality that returns the decimal piece. And in the second output, this one here, we're using integer, meaning ignore the remainder piece, and it's just returning the whole number, the result of that division. Questions here? Let me send this. Functions commit, yes, and I'll send that on to my repository. So that's the example for very simple examples, right? So easy examples, and then we're also like trying to understand that we have to code, test our code, and after we test our code and it's passing, then we can use it in main. Okay, so that way when you get to your homework, you're not struggling to follow the steps. That's my hope. Okay, so we'll go now to operator precedence. So let me stop here.